Namaste everyone. Welcome back to the refraction class. Hope you are waiting for the class, right? You are not forcefully sitting on the in front of the mobile or camera or a laptop. So we were discussing about some problems in the previous class. We will go back to the problems only. Today we will finish the problems related to whatever the topics we have done. Then we will move forward with the theory. Some 3 or 4 problems we have finished in the previous class. Today we will also have again some 3 or 4 problems. Now going back to the next problem. A 10 millimeter long pin is placed vertically in front of a concave mirror. A 5 millimeter long image of the pin is formed at 30 centimeter in front of the mirror. Focal length of this mirror is. So we will spend some time in the problem now because we know some theory. In a concave mirror, whenever the object is beyond center of curvature, image is between F and C. When the object is between F and C, image is beyond C. When the object is at C, we get image at C. Only when the object comes within the focus, we get image inside the mirror. So here the problem says a 5 millimeter long image of the pin is formed 30 centimeter in front of the mirror. So we got one clue. What is that clue? Concave mirror forms virtual image only when the object is within the focus. This image is in front of the mirror. In front of the mirror means it is a real and inverted image. That is sure because concave mirror always forms image in front of it. That is only when it is real. Inside the mirror we get erect image. So this is inverted image, it is real image. And that is main clue that we have got. And focal length they are asking you. And 5 millimeter long image is formed. And you see this again, one more clue in the problem along with the theory. 10 millimeter long pin, right? 10 millimeter long pin, but 5 millimeter long image. Can you guess where is the object? 10 millimeter long pin, object height is more, image height is less. So it should be diminished part is always between focus and center. Anything between F and C is smaller. Anything away from C is larger. So object should be away from the center, image should be between F and C. So 25% of the problems we have cracked. Remaining data and you have to use and you have to get the answer. That's all. Theoretical part we have cracked it because we know that it is a concave mirror given. Image is formed in front of the mirror. That means image is inverted and real. And image is smaller in size than the object. So image should be between F and C. Object should be beyond C. So they have asked you what is the focal length of the mirror. Now coming back to the board, let us solve it. Now a 10 millimeter long pin. So I will, with the knowledge of what the theory we have. So this is focus, this is center, and 10 millimeter long pin is placed in front of the concave mirror. Place the concave mirror in such a way that the light travels along plus x-axis, and this is center, this is focus. Object should be 10 millimeter long, it should be away from the center, image is smaller, 5 millimeter. So these are all the things we know. And okay, center, focus. This is object distance, given, not given. Only height of the hand, object of the pin is formed at 30 centimeter in front of the mirror. So a 5 millimeter long image is formed at a distance of 30 centimeter in front of the mirror. So what the focal length you have to get is, one thing it is negative. Divide it into coordinate system. This should be negative. And again another thing is it should be less than 30 centimeter. So 2 clues you have now to verify the answer whether it is correct or not. Focal length should be negative and it should be less than 30 centimeter. So we have the data, object image distance. We want to know what is object distance, but we know the magnification cases, right? So using that we have to do that. Now formulas for concave mirror are 1 by f equal to 1 by u plus 1 by v, and magnification is minus height of the image by height of the object, h dash by h, that is equal to v by u, right? Right, so not like this, h dash by h, that is equal to minus v by u, right? So now we will use the formula. First we will use this one because here we have more data than this. Here unknown things are more, here known things are more. So h dash by h we know. What is h dash? h dash. So applying this formula, h dash, height of the image, yes, 5 millimeter below the principal axis, minus 5 millimeter 10 to the power minus 3, divided by height of the object above the principal axis plus 10 millimeter is equal to minus, in the formula here, v, image distance is here, minus 30. Of course, I could have converted it into meters, but you have one more centimeters here. What the object distance you get will be in centimeters. So we will get satisfied with centimeter only. So this is 30 centi and whatever u is centimeters. So this minus is along with the formula, this minus is for its position on the left hand side. Because from the pole, when you measure it, you have to go along a direction which is opposite to the direction of incident light. Okay, now what is u? U should be negative because it should be in the other side. So if you get u, substitute it here, you will get f. What is u? U should be, and this gets cancelled, and this is 2 times, minus is here, this minus and this minus I can cancel, but 1 minus remains. Bring u here, 2 here, minus 60 centimeters. U is minus 60 centimeters. So what is f? 1 by f is equal to 1 by u plus 1 by v. 1 by minus 60, of course formula contains plus u, but u is in this side, minus 60, of course you have got it as minus 60, minus 1 by v, this is plus 1 by v, v is minus 30, so minus, okay, not this minus, plus minus. If we are not, in order to avoid confusion, I'll do it like this, 1 by minus u plus 1 by v over minus 30. So what is the answer? Focal length should be negative and it should be less than 30. So 60 common I will take. If I take 60 common, 1s are minus 1, 2s are minus 2. So what is the answer? This is minus 3 by 60. This is 1 by f, remember. So what is f? F is equal to minus 60 by 3, that is equal to minus 20 centimeter. See this answer, whether this satisfies all your theoretical knowledge. Exactly. 20 is here. See, minus 20 is here. 40 is here. 60 we have got this one. It is away from this one. Between 20 and 40, this is 20, this is 40, and object is away from 40. Between 20 and 40, this object distance is present. 20 and 40, that is correct. Focal length is within that distance, so everything is correct. In terms of sign conventions, in terms of positions, everything it is correct. Okay, so that is the answer. So focal length is minus 20 centimeters. We will move on to the next problem. Yes, similar problem. Yeah, a small candle 2.5 centimeter in size is placed 27 centimeter in front of a concave mirror of radius of curvature 36 centimeters. At what distance from the mirror should a screen be placed in order to obtain the sharp image? Describe the nature and size of the image. Okay, answer, you can see the answer, but we have to analyze this. Right, what is the problem? It's a concave mirror. One clue. A small candle 2.5 centimeter in size, that is its height. 2.5 centimeter is the height of the object. Placed 27 centimeters, object distance. Radius of curvature of the mirror is 36, it is concave, minus 36. Focal length is minus 18. At what distance from the mirror a screen should be placed? Screen is used to get the image, so image position, image distance. Where you have to place the screen so as to get the image on the screen in order to get the sharp image. Describe the nature and size of the image. Okay, okay, now we will list the problem. So list the data. This is a concave mirror and this is focus and this is center. Now, do you have any clues here? Yes, radius is minus 36 because center is in this side. So focal length is minus 36 by 2 minus 18 centimeters. One data. And height of the object, h dash is height of the image. Height of the object is 2.5 centimeter. Let everything be in centimeters. Then object distance is minus 27, it is given. Object is placed at a distance of 27 centimeter from the mirror. Radius curvature is given. So what is V? Question mark is for V. V should be negative because if the image is formed on the screen, then it should be real image, because for virtual images which are formed inside the mirror, no screen is needed. Now the screen is given. Where you have to place the screen? Somewhere here to get the image. That is the question. So 1 by f is equal to 1 by u plus 1 by v. That is our formula, and m is equal to h dash by h is equal to minus v by u. So we will substitute. I think we can use this formula directly. Focal length is known, object distance is known, image distance has to be found out. 1 by f focal length minus 18 is equal to 1 by u, 1 by minus 27 plus 1 by v. 1 by v is to be found out. That implies, bring this here, 1 by minus 18 plus 1 by 27 is equal to 1 by v. Okay, common denominator you can take it as 54, I think. So 54 common denominator, then 18 3s are plus 27 2s are. That is equal to 1 by v. That implies 1 by v is equal to minus 1 by 54. V is equal to minus 54 centimeter. Okay, that is the place where you have to keep the screen. V is equal to minus 54 centimeter. That is the answer. Okay, so that is the image distance. There you have to place the screen. Now, what about the, and if you just look into the object distance and image distance, now itself we can conclude. Object distance is 27 and image distance is minus 54. That means image is formed away from the center, object is between a focus and center. So it is enlarged, inverted real image. So how to prove it? Take the formula of magnification. M is equal to h dash by h is equal to minus v by u. What is h dash? Don't know. Height of the image. And it should be inverted somewhere here, right? It should be here. Some image is at 54. So away from C, it should be here. Object should be here. So h dash by h, height of the object, can 2.5 centimeter above the principal axis is equal to minus of image distance. We got it as minus 54. This minus and this minus. This is minus 54. U is also minus on the other side. Minus 27. Everything is in centimeters, so we don't have any confusion here. So what is h dash is equal to, this minus will get cancelled, this minus will remain minus, and this is 2s are minus 2.5 into 2, that is minus 5 centimeters. So it should be larger than the object. Object height is 2.5, this is double. So a larger image, inverted, real is formed. We have the answer. Image is real, enlarged and inverted, formed of height 5 centimeters. But 5 centimeters is not written in the answer. So easy problem. Now you have to carry on with such problems. Okay. If you have the theory background, then it becomes very easy to conclude whether your answer is right or wrong. Don't depend only on mathematics. Mathematics is only for application, but you shouldn't underline the answer whatever you get. You should just compare it whether it is in agreement with the theory. Okay. Next problem. A tank is filled with water to a height of 12.5 centimeter. Apparent depth of a needle lying at the bottom of the tank is measured by a microscope. So you can focus a microscope, you can find out at what depth it is. And if the image gets shifted by some centimeter, then you have to shift the microscope also. I will explain it. Now see the problem. So apparent depth is measured to be 9.4. What is the refractive index of water? If the water is replaced by another liquid of refractive index 1.63, then what distance should be the microscope have to be moved to focus the needle again? So answer is given. Refractive index of water is 1.33 and distance by which the microscope should be right. So a pin is placed inside the beaker and a tank is filled with water to a height and a pin is inside the beaker. Apparent depth of the needle lying at the bottom of the tank is measured by the microscope to be 9.4 centimeter. We will write all the values. Okay, one is a water tank. So let this be the water tank. Okay, I will keep the microscope also. So you will have an experiment next year. It is like this. We will analyze that experiment. Then you will understand what is the problem. Now what we will do the experiment like this. You have used a traveling microscope for surface tension experiment. It has a vertical scale, horizontal scale. You can move side by side, you can move to the height wise also. Y-axis and x-axis motions. Now suppose that the microscope is here. Okay, and you are focusing it somewhere here. Now you focus it here. Let the pin be here. No water, no liquid. Focus the pin to this. Take the reading. I will give you some values so that it becomes easy to understand. Microscope is here. Now you can see the image of this pin and take a reading. Suppose this scale runs like this. Suppose this height is say some 5 centimeters. This reading is 5. 0 is here. Up to this. Okay. Pour water into this. Let the water be poured up to this. So this is real depth. Am I right? This is real depth. Now try to see through the microscope. You can't see the image now. Can you tell me why? Because it is like as if you focus a camera to a small child. If you want to take the photograph of the child, focus the camera to the child. And when all the lenses and everything are adjusted, you get the clear image. Suppose the child runs away. What you can do? You will have to refocus it. Instead, you can do one thing. How much child has moved away, you too move by the same amount forward. That becomes easier. So if you have already focused to the child, if the child moves by 1 meter away, you too move by 1 meter forward. Then always the focus keeps itself like that. So now this is focused here when there is no water. But as soon as water is poured, you know there is a normal shift. Image shifts here. This is object, this is image. By how much image gets shifted upwards, what you call normal shift? If you want to see this image, because now the microscope is focused here. If you want to see this image, this appears to be blurred. If the child comes nearer to you, the image becomes blurred because it was focused when the child is away. If it comes forward, you too move by the same amount backwards. So what I can do is, in order to see this image, by how much the image is shifted here, by the same amount you shift the microscope so that you will get the image back. So just keep on lifting the camera. That is the microscope. Microscope is the camera for us now. You just go on shifting the microscope till you see the image again. This is the position where this is focused. Right? Now suppose this position is 7 centimeter. I'm giving odd values now. Then how much this is shifted? 2 centimeter. It is same thing. So when the object is here without liquid, focus was here. When water is poured, image shifted, appears to be shifted normally up. That is normal shift. And in order to get this image back to the vision, you have to shift the microscope also upwards by the same amount. So this height and this height should be same. So this also should be 2 centimeter because it has gone from 5 to 7. And the experiment continues. It is not over because here we have got only normal shift now. But what is refractive index of the liquid? Real depth by apparent depth. That is the experiment, correct? Now, what you have to do is, you put some something on the surface of water, say some dust particles or anything, something to float on the water. Now, can you see this in this position? No, not possible. If you want to see this, now this microscope is focused here. You have to shift the microscope by again this much amount. Shift the microscope still by a height so that it gets focused to the surface of water, because here it is not focused to the surface. Shift the microscope. What is this shift? That shift is nothing but this shift, because this was here, this was focused here, so this shift is exactly equal to this shift. Now can you calculate? And if I name this as reading R1, reading R2, reading R3 here, this is I will delete these values. I will name it as R1, R2, R3. Now is R3 minus R1 real depth from here to here, from here to here? Is it so? Then it is R3 minus R1 divided by what is apparent depth? Apparent depth is from here to here. These two positions correspond to these two here. That is R3 minus R2. This is the formula. So you take the readings in the traveling microscope, you divide this, you will get refractive index. Very easy problem using the normal shift method. So that is what is given in the problem here. We will go back to the problem. There is a tank and inside the tank there is a pin like this. So there is a pin. Now they say that a tank is filled with water up to a height of 12.5 centimeter. This is 12.5. Tank is filled with water up to a height of 12.5 centimeter. The apparent depth of the needle lying at the bottom of the tank is as measured by the microscope is, this pin appears to be here. Apparent depth as measured by a microscope is found to be 9.4 centimeters. This is 9.4. Okay? Apparent depth. Apparent depth is from surface where do you see, right? Where it appears to be. Real depth is actually where it is kept, and depths are all measured from the surface of water because we are outside. So depth is from the surface. Apparent, real. Okay, this is normal shift. That is given 9.4 centimeter. What is the refractive index of water? So that is question mark. Okay, then if water is replaced by another liquid, okay, that is the next part. We will do this one. What is the refractive index? Refractive index is very simple. Real depth by apparent depth. What is real depth? Real depth is 12.5 centimeter, and let the other one be also centimeter. Apparent depth is this one, direct one. 12.5 by 9.4. So you calculate it yourself. 12.5 divided by 9.4. Answer is 1.329. That is 1.33 almost. 1.329. No unit for refractive index because it is centimeter by centimeter, distance by distance, Sine by Sine. That is the first part. Whatever the next part. If water is replaced by a liquid of refractive index 1.63 up to the same height. Now this is 1.63. Next part. Up to the same height, I fill the beaker or tank with the medium of refractive index 1.63. By what distance would the microscope have to be focused, lifted to focus it again? Now, already the microscope is focused to this image. Now, if the image gets shifted to some other position, by how much it has to be lifted? Okay. Now we will see what is the real depth, right? By what distance the microscope has to be shifted. Okay. Now it is at a depth of 9.4 centimeters. When it is water, when this is filled, what is apparent depth we will calculate. Now, refractive index is equal to real depth same by apparent depth I don't know. That implies apparent depth is equal to 12.5 divided by 1.63. What is this one? Apparent depth is 12.5 divided by 1.63. 1.63. That is equal to 12.5 divided by 1.63. It is 7.66. 7.66 centimeters. This is the new apparent depth. So shall I indicate it here? It is a little bit lesser than this. So here 7.66. That means already our microscope has been focused here. Now it has to be refocused here because the liquid is different, shift is different, apparent depth is different. By how much the microscope has to be lifted? That is this difference, this one minus this one. So the shift in the microscope required is the original apparent depth minus 7.66. That answer comes to be almost 1.73 minus 9.4. Yes, that is equal to 1.73 almost. 1.73 centimeters. By this much it has to be shifted up. Very easy problem. Okay. We will move on to the next problem. We are going to do the experiment of this type. Yes. A fish is 40 centimeters below the surface of a pond. How deep does the fish appear to an observer directly above? Direct problem, right? Actually it is at 40 centimeters. At what depth it appears to be? Very easy. N equal to real depth by apparent depth. You know this. You can do it yourself. If N is real depth by apparent depth, what is apparent depth? Real depth by N. real depth is 40, by n is 4 by 3, and 4 will be in the denominator, 3 will come to the numerator. 120 divided by 3, that is 120 divided by 3 is equal to 40, right? No. A fish is 40 centimeter below the surface of a pond. How does the fish appear to an observer directly above, given refractive index of water? So real depth by apparent depth. Apparent depth is real depth by n. 120 by 4. Yes. 120 divided by 4. 120 divided by 4 is 30, right? 30.1 centimeter below the surface. Actually, it should be 1.33. Okay. You can do it yourself. I leave it to you. It's direct one. Just rearranging the formula. Okay, we will go to this one. A small air bubble is inside a transparent cube. This is very easy and a different type of problem. Very important. How to analyze it, it is the only thing which is required. Read the problem. A small air bubble is inside the transparent cube of side 0.1 meter. When viewed from one face, it appears to be at a depth of 0.06 meter. And when viewed from the opposite face, the bubble appears to be at a depth of 0.08 meters. Calculate the actual distance of the bubble from the first face and also the refractive index of the material of the cube. Okay, no calculator is necessary. Okay, you have your brain, so you can use it. Now, coming back to this explanation. Now suppose you have a glass cube like this. That is a transparent glass cube. I will give you the data when I solve the problem. If I have a glass cube like this. Now, suppose this is some object inside the glass tube, say air bubble, right? And remember, when that object or some air bubble need not be exactly at the center. It may be at some other place. So when I view this air bubble from this side, it appears to be shifted somewhere here. Now this is the real depth and this is the apparent depth. And objects need not be only at the bottom. Okay, fish can be anywhere inside the aquarium. It need not be only at the bottom. So this is real depth, this is apparent depth. Now I will invert this. Now the real depth becomes less, and so will be the apparent depth. It will also be less. So there is a difference. So when I view it from one side, the bubble appears to be at some depth. When I view it from another side, bubble appears to be at some other depth. And when I view it like this or like this, real depth is different, apparent depth is different, but one thing is common, that is the glass slab, that is refractive index. So in both the cases, when you apply n equal to real depth by apparent depth, RD and AD will change, but n remains the same. Correct? So that is how we have to proceed. Very simple problem. Now, I will write the values. So I will take a glass slab. I will take it as a square shape or a rectangular, whatever it is. I will mark a air bubble. And let us imagine that this is the real air bubble. Okay? A small air bubble is inside a transparent cube of side 0.21 meters. So let this be 0.21. All the sides are 0.21 meters. When viewed from one face, it appears to be at a depth of 0.06. So I will call this as first face, this is second face. This appears to be here, and this is real depth. Okay, this is 0.06, that is apparent depth. When viewed from this side, first face. When viewed from the opposite face, the bubble appears to be at a depth of 0.08. So this is the position when I view it from here. If it is viewed from here, this is I, and when viewed from here. So like this, the cases are different. So here it appears to be 0.06, here it appears to be 0.08 meters. Both the times you are observing the same cube, so refractive index is same. Refractive index of the material of the cube and what is the actual depth from the first face. Okay, n is common, so we will write the formula from this face. What is the formula from this face? N, refractive index. Real depth, I will take it as RD by, that is from the first face, real depth, or I will take it as X, real depth, X, divided by apparent depth, 0.06. I will take it as equation 1. Now what is the real depth from the second face? This one. This is the real depth from the second face, that is 0.21 minus X, this total depth, the thickness of the glass cube minus this x, that is this distance. So if you write the formula from this phase, what is n is equal to? Same refractive index, same material, right? Real depth is 0.21 minus x by apparent depth. What is apparent depth? 0.08. Now left hand sides are same for these two equations. Why can't be the right hand sides? So x by 0.06 is equal to 0.21 minus x by 0.08. Okay, I can take it as 6 and 8 because 0.01 is common in both, that I can cancel. 2 3s are, 2 4s are. 4x is equal to, what is here? 0.63, 3 into 2, 3 into 1, minus 3x. I'll bring this here. What is 7x equal to? That implies 7x equal to 0.63. So what is x equal to? 0.63 divided by 7, that is equal to 0.09 meters. The real depth of the bubble from the first phase is 0.09. Okay, this answer is 0.09 meters. From the first phase, it is 0.09. From the second phase, of course, it is 0.09 subtracted from 0.21. That is minus 0.09. That's what you have to do. Now, what is the refractive index? Substitute this value in any one of the equations. I will substitute it here. N is equal to, from the first phase itself is x. 0.09 by 0.06, 9 by 6. It is 1 by n is equal to, it is 3 3s are, 3 2s are, 1.5. That is the refractive index of the material. Very easy problem once you understand what is the situation behind this. So only the thing is, whatever the phase you prefer, refractive index is same, but real depth, apparent depth keeps on changing. So answer is the right. Now we will move on to the next problem. Yes, important problem, this one. You must be able to work out these problems even in the entrance exam hall. And of course, angles will be given in such a way that you will work it out very easily, right? Now read the problem. A small bulb is placed at the bottom of a tank containing water at a depth of to a depth of 1 meter. And so there is a tank containing water up to 1 meter depth. Find the critical angle for water air interface. Okay. Also calculate the diameter of the circular bright patch of light formed on the surface of water. Okay. So it is like you need some explanation for this. Read the problem once. You read the problem. Okay. Right. So you have a bulb at the depth of a water, right? Depth of water at a certain depth, 1 meter, and you have to find out what is the diameter of the circular patch of light. Yes, it will be like this problem. Now suppose you have to imagine it in 3 dimensions. Your animation inside the brain should go in 3 dimensions. Okay, I will explain it. You will get the idea. It is like this. Say this is the pond. This is 1 meter deep, and here we have a bulb. Bulb will emit light in all directions. Now, a ray of light incident normally, angle of incidence is 0, not 90 degrees, because normal is also in the same direction, I0, R0. Ray of light passes undeviated and no deviation at all. Consider another ray of light incident like this. Let that be the last ray which is moving out of this surface. Say this goes out. Okay, let this go out. Let us select another ray of light which is just grazing, right? You know this in total internal reflection. Let us consider one more ray just coming back to the back to water. So this is the last ray which gets a chance of going out. This ray clearly gets a chance of going out. This is the last one which grazes, and any ray out of this will come back. So you ask, and can you get the same situation here also? This ray, you ask this ray, are you going out? Yes sir, I can go out, but I bend away from the normal. Okay, let it be. Take this ray. Are you going out? Yes, sir. What about this ray? Sir, I got an opportunity to go out very, very, very closely like this. I am the last person got the chance. What about this ray? Sir, I came back. Because for me, angle of incidence is greater than critical angle. For me, this one, angle of incidence equal to critical angle. So last chance. Now, for a person observing from here, you ask him, can you receive this light? Yes, I can receive. I can receive this ray. I can receive this ray. I can receive this one. Can you receive this ray? Ask this person. No, this ray cannot be received. You ask him, what is the last ray that you have received from the bulb? That is this one and this one. Am I right? They are the last rays of light received by the person outside. He can't receive any light from the bulb outside these two rays, outside this range. Now, how it will look like in 3 dimensions? You will have surface of water like this, right? You will have bulb inside. Rays of light will be coming from the bulb into the surface of water like this. The normal ray, we can get it. A ray incident at some angle, we can get it. A ray which is incident at last critical angle just comes out, we can get it. What about the ray coming here? Under total internal reflection comes back. We can't see that ray unless it comes to our eyes. That ray reflects back. So imagine this in 3 dimensions. How? A ray of light coming from the bulb here just undergoes total internal reflection. That means critical angle of refraction is 90. It just comes out, you can see that. A ray of light coming here just goes back. You can't see that. For such a ray which is under grazing here, can't you get a ray here which is also grazing? Yes. What about here? Can you get a ray of light here? Here, inside, here, here. So all such grazing rays will be in a circle. Can you imagine? Yes, you can imagine it like this. Say, it is like a cone. All these rays, will they form a cone? Can you imagine a cone? You can imagine a ray here, here, and you can imagine a ray here also. You can imagine a ray here also, because water is like this, and here also. So get all those rays. Are they in the form of a circle like this? So it will be like this. If I can form a cone of rays like this, I can make the surface parallel. Yes, like this. Suppose this is the point where you have bulb, surface of water. A ray of light coming from here undergoes grazing refraction. You can get it outside. A ray of light just outside this cone undergoes total internal reflection. You don't see that. This ray grazing, this ray grazing. Imagine it in a 3 dimension. You can get a cone of rays coming out. These rays come out because for all those rays, angle of incidence will be lesser than critical angle, and for all the rays outside this cone, angle of incidence will be greater than critical angle. They return back. So if the bulb is switched on inside water, what do you see on the surface of water? Only a circular patch of light. That's all, nothing more. You will see a circular patch of light because light rays come from this, including the normal ray and all the rays at the critical angle. You won't receive the rays outside this. So remember, and if you take the reversibility of light, this problem, I haven't explained that point while explaining the theory. Purposefully I left it there. Suppose you are inside water. You are inside water. You must receive the rays from outside, right? Sir, if you are here, can I receive this ray? Suppose there is a tree, and if the ray of light is coming from the tree, can I receive this? Yes, possible. Because the ray follows the principle of reversibility. Sir, can I receive a ray of light from a tree, or somebody is standing outside the swimming pool? You are inside the swimming pool. If somebody is standing here, his ray of light is falling here. Sir, it is undergoing refraction like this. Can I receive this ray? No. You can't receive this. Because any ray of light going from inside to outside undergoes total internal reflection. Any ray of light incident here will undergo refraction somewhere else, not here. So for a person inside water, for a fish inside water, outside world appears to be contained in a circle. It receives only those rays of light within the circle, not outside the circle. Outside the circle, rays will go somewhere else and it won't be received by the fish. And fish will be able to see this person only when it reaches here. As it swims and receives here, it can receive this ray. Otherwise, it cannot receive this ray. A ray of light going from inside will undergo total internal reflection. So for a fish inside water, outside world is bigger because everything appears to be away and away, but it contained in a circle. So if you are swimming inside water and if the sun is setting here, you must look into the sun at a very particular angle, then only you can see the sun. Suppose this is the horizon and if the sun is setting somewhere else and you are inside water, you can see the sun only when you look at some angle. If you look at somewhere here, you can't see the sun. This ray is not coming from the sun. So that should be a particular angle. Okay, now coming back to the problem. After all the stories, we have narrated everything. Now come back to the problem. Here is a bulb at a depth of 1 meter inside a pond, and refractive index is given 4/3. This is 1 air because nothing is told about it, and find the critical angle of water interface so as to diameter. Say this is the last ray which is undergoing refraction, and any angle greater than critical angle makes the ray to come back. And here is one more such type of ray undergoing grazing refraction. This is a normal ray which is without deviation moving out. All the rays within this cone, so I can assume that cone to be like this. 3-dimensional diagram, it is very difficult to draw in the, so it will be like this here, right? So that's not a nice cone. Yeah, it is here. So it will be like this. So it will be a cone of rays like this. All the rays in the edge of the cone, so you have to imagine it in 3 dimensions. So here you will get a circle like this. They are asking you what is the diameter of the circle. We will calculate the radius because it comes in a triangle. Now you have understood the problem, not the solution. Now the solution runs like this. This is radius, this is 1 meter depth. Now this is the critical angle. You have a relation between critical angle and refractive index. When the ray of light is incident at the critical angle, angle of refraction is 90 degrees. And if n is the refractive index given for this medium, if this is air, you just apply the general law. N into sine theta. So n into sine IC, n1 sine I, n2 sine R. n2 is 1 sine 90. So you will get a relation between refractive index and critical angle. Sine IC is equal to 1 by n, that is 1 by 4/3, that is equal to 3/4, which is 0.75. So from refractive index and critical angle, you will get critical angle. What is IC? IC is sine inverse of 0.75. So you need a logarithmic book now, class table. What is sine inverse of 0.75 you have to calculate. Once you get IC, so shall I shift this IC here? Can I shift this IC here? Can I do that? Because why, sir, why did you find out critical angle? They are asking you the radius and diameter. Why? What is the use of finding this? Once I get this IC, I can do it very easily because in IC, R is the opposite side and we know the adjacent side. So if you know tan IC, you can do that very easily. So tan IC gives you the opposite side by adjacent side. Adjacent side is known, opposite side is needed, IC is needed. IC can be obtained from this. So you will go for sine inverse of 0.75 because n equal to 1 by sine C. We have derived this in the previous class. N equal to 1 by sine IC or sine IC equal to 1 by n. So we have put it as 1 by n is given 3/4, 0.75. So we will go for sine inverse of 0.75. Where is sine inverse of 0.75? A number which is very close to this is enough. Sine inverse of 0.75, we will search it. See, you know sine 45 is 1, right? And sine theta values are increasing as theta increases. It should be more than 45 because, it should be that is tan 45. Sine 45 is 1 by root 2. 1 by root 2 is 0.707. It should be more than 45. Where we will get it? Tan 45 is 1. Sine 45 is 1 by root 2, which is 0.707. So it should be 0.75 now. Sine 45, it should be more than 45. 0.75, 0.754 you have. You want only 0.75. You see, 0.7504 something. Can you see that? Is it visible? of course I have enlarged it and it may be blurred a little bit, 0.750 something here, right? So that is 48 degrees and 0.7508 comes in 40 minutes. 40 minutes you divide it to 60 because each 60 minute is 1 degree, right? So divide it to 40 minutes by 60. It will be 0.7 something. So we will see the answer first. 0.7575, it will be here, 0.7508. That will be enough for us. 48 degrees, 30 minutes. No, it is 40 minutes. 48 degrees, 40 minutes. Suppose it was 30 minutes, we would have written 0.5 degrees. So every minute, if you want to calculate, so we got the answer as coming back here, 48 degrees, 40 minutes we got. So if you have 60 minutes, divide it by 60, 1 degree. 30 minutes, divide by 60, it is 0.5 degree. If you have 15 minutes, it is 1/4 of the 60, right? Divide by 60, it is 0.25 degree, sorry. Now what is 40 minutes? Divide by 60. What is this? 6 7s are 42, 8 remaining. 8s are 48, 2 remaining, 3 something, right? 0.833. So 0.8 I will take almost. So shall I write it as 48.8 degrees, right? Or 83 degrees, right? 48.8 degrees is enough. So this is 0.8 degrees, 40 minutes by 60. And actually in your logbook you have that degree part also in the column. I downloaded something which has no degree part. Actually degree will also be written in the minutes along with the minutes. So 48.8 degrees, that is enough for us. Now that is IC, correct? Now how to get the radius, diameter? Tan IC I have to follow. Tan IC is equal to opposite side divided by depth, this one. Tan 48.83 is equal to opposite side divided by depth is 1 meter. Now I don't have tan table, so you search for tan table. Let us go, find out what is tan problem. Let us go to the problem. In the problem it is given what is tan 48.83. Okay, yeah, it is 1.13 tan 48.13, because tan 45 degrees is 1, correct? If tan 45 degrees is 1, tan 48 will be just more than 1. It is 1.13. 1.13 is equal to r by 1. So r is equal to 1.13 meter. So what is diameter? Diameter is double this one, 1.13. That is equal to 2.26 meters. This is the answer. Okay. So that is the diameter of the circular patch. Suppose you are asked to find out what is the area of the circular patch, then you can do pi r square. Area is given by pi r square. So these types of problems are very important. So you can calculate this into 2.26. Is it meters? Yes, 1 is meter. Pi r square, so many meters square. You can do that also. And pi, this is 1.13. This is not diameter, this should be radius. Pi r square, yes, that is area. So, and you have to, this problem is a very easier one. So simply converting refractive index into critical angle, n equal to 1 by sin IC, one part, or sin IC equal to 1 by r, one part, and getting IC. And you can do it in another way also. You need not take tan IC. What you can do is, this is 1, this is r. Already you have sin IC, right? Sin IC we know, 1 by r. You can use sin IC itself. What you can do is, you can write this hypotenuse. Hypotenuse is equal to root of 1 square plus r square. You can do this way also. Root of 1 square plus r square is sin this hypotenuse. Now, you know what is sin IC? 1 by n, 1 by 4 by 3, right? 4 by 3 is refractive index. That is equal to 3 by 4. And sin IC is equal to 3 by 4. which is also equal to, now you can write opposite side by hypotenuse, opposite side divided by hypotenuse. So you need not use this log table at all. You will directly get this from here, r. So just cross multiply and square it, you will get the answer. This is also possible. I think whichever is easier, you do that. And you must be able to do this problem in the reverse order also. How? Reverse order. Suppose radius is given, how to find out the refractive index? If radius is given and depth is given, first find out the critical angle. Or sin IC you have to find out. Opposite side by depth, sin IC. Then you can find out IC. And then sin IC is 1 by n. So you must be able to put it in the reverse order. But you must be so aware of this problem that in the entrance exam there should not be any confusion. All these stories must be already printed and you must go very fast. And all the data will be such that you will get the answer very quickly. You won't be given such odd data to use logbook and all. So you can get the answer immediately. So these are the problems, and we will come with more problems later. Then we will continue the theory in the next class. Thank you. Do well and work out more problems, right? Don't keep quiet. See some easier, more problems. Thank you.